90 days on Linux. No regressions reported, no missing features, no looking back. That is not an architectural conclusion. That is a survivor report. The actual question: did this migration succeed because Linux is ready for general desktop workloads, or because this specific user's workload portfolio happened to fall inside a compatibility envelope they never mapped? The modern Linux desktop stack is not what it was in 2015. The kernel ships hardware support for most Tier 1 consumer devices. Wayland Compositor's GNOME Shell, KDE Plasma, Sway handled display at the protocol level with reasonable GPU offload. Flatpak and AppImage have closed most of the application gap. Slack, VS Code, Spotify, Chromium, LibreOffice all ship as distribution-agnostic binaries. The Proton compatibility layer runs a substantial slice of the Steam catalog with 5 to 15% CPU overhead and acceptable frame-time variance. Pipewire replaced Pulse Audio and Jack under a unified audio graph with configurable buffer sizing. On the surface, this is a complete, production-grade desktop operating system. The migration narrative is credible. The survivorship problem hides underneath it. Here is the architectural flaw the 90-day report does not surface. Linux's compatibility surface is not a static guarantee. It is a runtime contract between your specific hardware, the kernel version you are running, and the driver model each hardware vendor chose to ship. That contract is renegotiated on every kernel update. NVIDIA's proprietary driver requires DKMS module recompilation against the new kernel headers. If the driver version is not yet ported, which happens on point releases, your display manager fails to start and you are dropped to a TTY. AMD's open-source kernel driver is solid, but ROCm, AMD's compute stack, covers roughly 60% of CUDA's operator surface on comparable hardware. That gap is invisible on a 90-day casual desktop migration. It surfaces at day 91, when you need to run a local inference workload and discover your GPU is a first-class gaming device and a second-class compute device. The flaw is not that Linux is broken. The flaw is that compatibility is workload-dependent at runtime, and the migration story is told exclusively by users whose workloads never triggered the gap. Put concrete numbers on the constraint surface. Pipewire's minimum hardware-independent latency floor sits at 5 to 10 milliseconds, with a standard 48K HZ sample rate at a 256-frame buffer. ASIA, on Windows, reaches sub-millisecond round-trip on the same hardware. That delta is invisible for casual listening, but eliminates Linux from any latency-sensitive professional audio pipeline. Proton's DirectX to Vulkan translation layer introduces CPU overhead between 5 and 15% on CPU-bound titles, and more on titles with aggressive anti-tamper modules. Easy Anti-Cheat requires a signed kernel module, which breaks on distributions enforcing fully free software builds. NVIDIA's Open Kernel module, shipped since driver 515, still requires the proprietary user space blob, meaning any distribution enforcing a fully open firmware stack fails at the GPU boundary. These are not edge cases. They are load-bearing constraints that 90-day reports built on browsing, office work, and casual gaming simply do not exercise. The architectural correction is to treat OS selection as a workload compatibility audit, not a user experience preference test. The fix has 3 components. First, enumerate your workload portfolio before migration, not applications but compute primitives, GPU compute class, audio latency floor requirement, DRM content requirements, and enterprise identity integration surface. Second, map each primitive against the Linux ABI surface for your target hardware. Verify whether your GPU has first-class ROCm or CUDA support under the current open kernel driver model, whether your audio interface ships an ALSA driver with the latency profile you require, and whether your enterprise SSO stack negotiates cleanly through PAM and SSSD without a proxy layer. Third, execute the migration inside a hardware envelope. You have pre-validated hardware where the driver story is settled and tracked in the upstream kernel, not aspirational. The correct migration sequence is audit workloads, validate hardware, then migrate. The 90-day narrative runs those 3 steps in reverse. This fix is real and it costs something. A pre-validated hardware envelope means you are not buying whatever is cheapest or newest. You are buying within a compatibility matrix, which typically means staying 1 generation behind the bleeding edge of GPU silicon where driver maturity is established. Locking to an LTS kernel and a stable Flatpak runtime reduces your update surface, but introduces a lag on security patches that ship mainline before they backport. The workload audit takes time. A non-trivial audit for even a small team will surface incompatibilities that require either a workload migration or a maintained Windows VM alongside the Linux host. That dual boot or VM fallback is not a failure mode. It is the honest architecture. Most production Linux desktop deployments that work reliably at scale run exactly this. Linux primary with a Windows VM lane kept warm for the 15 to 20% of the workload portfolio that hits the compatibility gap. The 90-day report is accurate. No missing features for that user's workload portfolio, which is the right outcome for a well-fitted migration. It is not a general architectural conclusion. Linux is production ready for the workloads it covers. The discipline is knowing, before you migrate, which workloads those are.